Abelian group. It is the form of group, but the subcategory of the group. It is the subcategory of the group, which is the pure form of group. What is Abelian group? What is the definition of the Abelian group? And what are the conditions for the Abelian group? Let me first give you the definition. According to the definition that we have, a non-empty set with a binary operation is said to be an Abelian group if it satisfies the closure, associative, identity, inverse, and commutative laws. A non-empty set, any non-empty set, a set of natural numbers, a set of whole numbers, a set of real numbers, and so on. Any non-empty set with the binary operation, like addition binary operation, multiplication binary operation, is said to be an Abelian group. This non-empty set is said to be an Abelian group if it satisfies the closure law, associative law, identity law, inverse law, and commutative law. What is the difference between the group and Abelian group? The difference is only the commutative law. For the group, we don't have commutative law. For the group, a non-empty set satisfies the closure, associative, identity, and inverse laws. But for the Abelian group, we have added one more law, which is the commutative law. The difference is only the commutative law. It doesn't have commutative law. Abelian group should satisfy commutative law as well. The rest of the laws are the same, what we have done for the group. Let A be any set, where A and B belong to set A. If A plus B belongs to set A, or A times B belongs to set A, then set A satisfies the closure law. Similarly, let A be any set, where A, B, and C belong to set A. A plus B plus C equals to A plus B plus C belongs to set A. Or A into B into C equals to A into B into C belongs to set A, which is the associative law. It means that set A will satisfy the associative law. Similarly, A plus 0 plus A equals to A, or A into E equals to E into A equals to A, which is according to the identity law. Set A satisfies the identity law. Similarly, A plus A prime equals to A prime plus A equals to 0 belongs to set A, or A into A to the negative 1 equals to A to the negative 1 into A equals to 1, which belongs to set A. It is according to the inverse law. Set A satisfies the inverse law. A plus B equals to B plus A, or A into B equals to B into A, which is according to the commutative law. Set A satisfies the commutative law. The only difference that we have for the Abelian group is this commutative law. We have commutative law extra for the Abelian group. For the simple group, we don't have commutative law. So if a non-empty set A satisfies all these laws, then we can say that set A is said to be an Abelian group. Look, the rest of the laws are absolutely the same, what we have done for the group. But for the Abelian group, we have added one more law, which is commutative law. For set A to be an Abelian group, it also satisfies the commutative law. Look, set A satisfies both the closure laws, closure law of addition, closure law of multiplication. So we have addition binary operation here and multiplication binary operation. Similarly, it satisfies both the associative laws, associative law of addition and associative law of multiplication. It also satisfies the identity laws, additive identity and multiplicative identity. Set A satisfies inverse laws, both the inverse laws, additive inverse or multiplicative inverse. Similarly, set A also satisfies the commutative law. Commutative law of addition, both the commutative laws, commutative law of addition or commutative law of multiplication. So if a non-empty set, which is set A, satisfies all these 5 laws, 1, 2, 3, 4, 5, all these 5 laws, then set A is said to be an Abelian group. Look, A satisfies the condition of the group. For the A to be a group, it satisfies these 4 laws, 1, 2, 3, 4. But when you add one extra law, which is commutative law, you can say that it comes under the subcategory of the group, which is Abelian group.